Hello, here is Ayrton Lastori. I'm the product manager for MySQL Heatwave database service in OCI. And today we are going to talk about the MySQL database service in OCI. Um, so the MySQL Heatwave database service is really a service that is big. It takes care of a lot of workloads. It works for transactional workloads like OLTP, analytics like OLAP, and also has built-in machine learning capabilities. So the benefits are the simplicity of transactions in real time. So you have everything in one service. It has unmatched price and performance. So it really cheap and very performant. And you can use it in OCI if you want, or even in a hybrid cloud deployment, or even in multi-cloud. So you can use, for example, MySQL Heatwave in AWS today. MySQL Heatwave database service is one database for all these workloads. So on the right, you can see that you can use machine learning tools. You can use Jupyter notebooks, Apache Zeppelin. You can use analytic tools like Tableau, Looker. You just connect to the MySQL as a regular MySQL, and it's accelerated for this use case. But today we are going to focus on the OLTP applications, which are the most popular usage of MySQL. So MySQL powers social applications, social media, e-commerce, fintech, SaaS. So MySQL is really popular. And in this space, OLTP is the traditional space where you can find MySQL. So our focus here is to talk a little bit about the benefits of the MySQL Heatwave database service for these OLTP workloads. Using it in OCI brings you a lot of benefits. So you can see that the productivity for database administrators, developers will increase a lot. We take care of the high availability aspects of the database, scalability. We take care of backups and restore, security and compliance, patching and upgrades. This is all automated by the service, and you have peace of mind to perform these tasks, these traditional tasks for the database. So it has also unbeatable price performance. We'll talk a little bit about this later. And this is a service that's developed and operated by the MySQL engineering team. This is the same team that develops the MySQL server, the community version, the enterprise version. And in particular for the service, we use the enterprise edition, which has plugins that are not available for the community, like the thread pool plugin, the data masking plugin, and this is all included in this service. So the service is available already in more than 33 regions, so 33 commercial regions. Here's a map, plus some government regions and dedicated regions for customers that buy the OCI dedicated region offering. So MySQL Heatwave database service is there and is part of this deployment. So you pay the same price on every region, and this is a differentiator from all other cloud vendors. So in OCI, you have always the same price, and independently of the region that you are using the service. So let's go a little bit deeper and talk about the productivity aspects. So MySQL database service is a fully managed service. We have this abstraction that we call MySQL DB system. So when you create a database, you create this object, this cloud object, cloud resource that abstracts a lot of things for you. For example, you just go to the console, create a DB system. it will, behind the scenes, we are going to provision a database for you. We will create a virtual machine, install MySQL, configure MySQL for you. But what all you need to do is to enter a few uh, information, like the configuration that you want for this database, if it's a standalone, if it has HA, if it's for OLAP and you want Heatwave enabled, and we provision an endpoint. So it's a IP address and port that you can connect to it using your client applications or MySQL clients, just as a regular MySQL database. So you don't need to care about all these provisioning details. And after in day two, we also will take care of upgrades, patching, and any other problem that you may face. So let's uh, take a look how it works in Preds. So let me just select here. Okay, so this is the OCI console. So if you come here, this is the home screen. To create a new DB system, you come here, database, MySQL, and then it will load a screen like this. So you select the compartment and you click create DB system. And here you give a name for your DB system. You give username and password. You select networking. So what's the VCN, the virtual cloud network that you want to place the endpoint of this database. You select a subnet. So we recommend a private subnet to keep your database secure. And then you can also configure the placement of the virtual machine. So if you want to put this in a different AD or availability domain, you can select here. You select the shape, which is the database size. So you have a lot of options. Like here, you can select the amount of CPUs and RAM available. So we support AMD, Intel, and a large number of combinations of CPU and RAM. Let me select this one, for example. Then you select how much storage you want. This is the where we will store your data, your tables. I'll keep the default like 50 giga. You can go up to 64, and we are enhancing to open to 128 terabytes. So there's a lot of flexibility here. If you change your mind, you can change this in the future also. And then you configure the backup plan. So we perform automatic backups daily, and you select the default retention for these backups. So let's keep as for 7 days. So I have the past 7 days of backups. You can also enable point in time restore. So if you need to restore a backup to a specific point in time, you can perform this operation. You have also other advanced options here, like if I want a specific MySQL configuration, change any MySQL variable, I can change here. I can import data directly from the object store. So while I create the DB system, I import the data. I can protect this from deletion for some accidents, like trying to delete something that is really important. So you can kind of protect this and click create. So when you click create, it will start to provision a new DB system, and with the configurations that I gave to in that screen, right? So while this is creating, let me get one that's already provisioned, so I can explain a bit more how it works. So in this case, this one is in this networking here. And after it's provisioned, it gives you an IP address, so I can connect to this IP address just using the regular MySQL protocol. Um, so you can also define the maintenance window. If you have a preference to perform maintenance, you can select a day in the week and a time. So that's convenient for you to perform the maintenance here. Um, you and also here you can see more details about the endpoints. In this case, I have an instance with read replicas. So I have a read write endpoint for my primary instance, and then I have a read endpoint to the replica. So they have different IPs. We'll talk a little bit more later. Here I can see more details about the read replicas that I have. In this case, I have one active, like you can see here. Um, if I have Heatwave enabled, I can see details about Heatwave here. My backups will appear here. So the automatic backups are created automatically once a day. And because in this case, I have the point in time recovery enabled, I can restore to a specific point in time. So I can see here that point in time recovery is enabled. And then, for example, for this backup here, uh, if I click restore to a new DB system, I can select a specific point in time um, to recover this database. So I can go back until my oldest backup, and I can select a specific time and minutes to restore. So another aspect that's important is channels. So channels are basically replication channels. I can configure inbound replication channels. So I can add here a channel that will replicate into this instance. So this enables a lot of use cases like hybrid deployments and disaster recovery. So this is mostly of the basic functionalities. Uh, and just to make sure we covered everything. So I hope it's clear that it's really easy to provision. It's just a few clicks, so you have your database deployed, and we ensure that you have good configuration for performance, good security configurations, and it's compliant. You have that fast data import option where when you create a DB system, you can already import data, and this is really fast. And you can have your backups managed by the service with this point in time recovery option. We ensure that your database is always up to date. So when we release the MySQL server version, we also make this latest version with the latest fixes available to the service on day one. So this is something that only we can do because we do both, right? We do the MySQL database service and also the MySQL server, and they are in sync. Uh, it has metrics and alarms. I haven't covered these in details, but you can see the in the database you have basic metrics and you can set up alarms. Also, you can automate tasks using Terraform, the CLI. There's an SDK available. This is all available for all OCI service and also for MySQL database service. And you have this flexibility as you grow. You can dynamically change the configurations. You can scale up the storage size online, so you don't need to stop your database to scale storage. You can enable and disable high availability, and you can add and remove read replicas and channels to your DB system. So in terms of security and compliance, it's always secure. So we enforce that you use private networks, you use security lists. So it's all enforced by the service. It's always encrypted. So your data we use OCI block volume behind the scenes, and it's always encrypted. We you can use data masking functions. It's an enterprise feature that is available for you. There's integration with OCI Identity Service. There's integration with OCI API Audit. We have enabled the password policy validation plugin, and we have more things like the connection control against brute force attacks. We we comply with this all these regulations and more. So you can take a look in this link if you want more details. But it's basically all the most demanded regulations that the marketplace requests. We comply with those. Um, a little bit about availability and scalability. So in terms of high availability, we use um, group replication as our technology for to replicate data. It replicates data at the database level, and you continue to see only a single endpoint and to connect to your database. When you deploy a high availability DB system, you just select here while you're creating your DB system, or you can enable and disable this feature after you deploy the database. But what it does behind the scenes, it deploys 3 database instances, and every database instance has a copy of the data. And because we use group replication, we ensure that the data is secure in at least uh, another database instance. So if something goes wrong, like there's a failure here in AD1, we fail over the endpoint to another instance automatically. And because we select 3 different physical locations, we can provide you 4 nines of SLA. The failover is automatic. You can also switch you over manually. And this feature is also nice for upgrades because we can perform the upgrades on your secondaries. And then when they are ready, we do a rolling upgrade. We switch over to the secondary, and then we upgrade your primary. So this gives you less than 1 minute impact during upgrades, and we ensure that you are running the latest MySQL version and all the operating system security patches. For read replicas, we also have a read-write endpoint for the HA part of the system, but we can have a read-only load balancer here in front of the replicas. So this is all built in the service. You connect direct to the load balancer, and this will send your selects, your read operations to the replicas. You can, of course, connect directly to the replica if you want to. But what this gives you is the possibility to increase the capacity for read intensive workloads. You can add and remove replicas online for horizontal read elasticity. It's really easy to deploy. It's a one-click operation as well. And as I said, you have the built-in load balancer that is based on this 5-tuple hash load balancer policy. So we get the source IP and port, destination IP and port, and protocol. So we ensure that the connections flow to the right replica. And the HA cluster continues reliable and ready for switchover because the replicas are independent from your read-write HA cluster. So this is really resilient and scalable. Here are some numbers how this can scale your read workloads. So if as many replicas you are adding, you can see that the TPS, the transactions per second, will increase. So we are talking about like 16 replicas will give you 6 million TPS for point select operations. And this is really nice for large deployments. And this benchmark used a regular AMD machine with 16 OCPUs and 256 GB RAM. Um, for the replication channels, just to highlight the use case here, so it's good for hybrid deployments. So you can have on your MySQL on-premise and also in other cloud vendors if you want, and replicating to OCI using this feature. So you just create a channel here. We have a helper to give you filters if they are needed to replicate from external source, like if you're replicating from AWS Aurora, we have the filters ready to use. You just select here, and this will make sure that the replication will work for you. And this is also useful for disaster recovery, for capacity bursting. If you want more capacity in the cloud, you can use this, and also, of course, to use the Heatwave capabilities that are unique to the service. Um, Also, it helps with live migrations with less downtime. And you can also use this feature to replicate from one DB system to another, like in different regions. So you have a disaster recovery solution. Regarding the performance and cost, so this is a comparison with Amazon Aurora. We used Intel machine in our side to make a fair comparison. Uh, 16 OCPUs, 256 gig RAM, and in Aurora we used Aurora V3, which is the latest available. And for this workload here, which is an in-memory benchmark, we could have 50% more performance than Aurora at 256 concurrent users. But it's really, all in all case, we are more performant, right? Another thing is we keep stable. Even if we increase the number of concurrent users, we can keep the performance stable. And here, the difference is we have the thread pool plugin always enabled, and thread pool helps with this use case here, where you need to deal with a lot of concurrent users and keep the performance stable. Also, we of course OCI infrastructure is offer us these machines which are really good, and we can take advantage of that. And because this is a service that's provided by the MySQL team, it has very good configurations in terms of performance by default. So you don't need to keep trying to turn the system because we already provide those for you. And this is also true for this other benchmark, which is IO bound. The other one was in memory. This is more IO intensive. So the data set is bigger. But also here we can see we have an advantage, a performance advantage. It's the same machine, but we use the OCI block volumes underneath, and we do data striping to take the most of the performance for the disk. So we can see that we have a really good performance for this type of workloads. And the best part, I think, is it's cheaper. If we compare, if we do a comparison here, like 1 year TCO, 100 OCPUs, 10 terabytes of storage, compared with RDS, it's 2.5x cheaper, and you can see it's even it's also cheaper than other offerings from other cloud vendors. Um, and Aurora is not here, but it will be even more expensive. So we are really competitive in terms of price. In here, we are comparing same shape, size, and price list, right? Um, and finally, the best thing, I guess, this is a service provided by the MySQL team. As I said, the same team that develops MySQL Community Edition, MySQL Enterprise Edition, the server itself. So we have a DevOps team that builds the service, operates the service together with the same team that develops the MySQL server. In fact, the MySQL server team also helps with operations. So we are learning a lot by operating the service. This makes possible to improve also the MySQL server, but we can offer the best experience that you can have as a cloud service for MySQL. So it includes Oracle MySQL Premier support. You don't need to pay anything extra to have access to the same thing that you would pay if you need to buy subscriptions. And yeah, so the operations is also we have a team that operates the service, and the engineering team is also operating the service to give you the best experience possible. Quick recap. So in terms of productivity, we saw that we have high availability, read replicas and channels. It's all there. Just a few clicks, and we take care of everything. Backups and restores, point in time recovery, it's already there, integrated. We provision the instance with the most secure and best practices and configurations. We take care of patching and upgrades. We can keep MySQL updated with the latest versions. You have a lot of automation options in OCI as a platform. We have unbeatable price performance. We are faster and cheaper, and it's backed by MySQL engineering team. So you can go there and enjoy. So if you want to try, go to oracle.com MySQL free. And if you want to learn more, oracle.com/MySQL, you can find links to the documentation, a lot of good stuff there, including the Heatwave part that is not covered in this presentation, which is really cool. You can find more information there. So thank you, and see you around.